Hello. Question number four. It's more straightforward. What I wanted to show you here is that in the classroom, I said this assumption is automatic. It's assumption. It's not an assumption. That's what I said. And this approach shows why I said that. And as you can see, it's very general. So this is all the assumptions we make. Then under those assumptions, it's our definition of gamma. So that definition of gamma and definition of psi. This is called psi. Gamma and psi can be defined this way, and then the assumption is automatically satisfied. So the first stage equation is not structural. So whenever you have endogenous variable and instrumental variable, you can set up the coefficient and the error term such that the error term is always exogenous. Like the instrumental variable is always exogenous, orthogonal to the error term. And then based on this definition, in this part I show that our second stage identification also works, which is also pretty straightforward. And also in part C, what I wanted to show you is in each step, in this step and in this step, we need invariability, the full rank condition for the second stage. The second stage invariability should be interpreted this way, which is equivalent to the invariability of the moment condition approach. So question number 4, it's most of you have done well, like nothing much to say. Just I just wanted to fill in what I mentioned in the classroom without showing. It's, as you can see, it's straightforward, and I want you to see the difference between the structural form equation and the reduced form equation. The reduced form equation does not require assumption of exogeneity. It's always satisfied by definition. That's the point. And let's go to question 5. This is tricky. This is not simple, but it's a straightforward extension of two-stage approach to kind of three-stage approach. What we do here is W and S. W, S are endogenous variables. I put names, but point here is endogenous. These are endogenous, and we assign one instrument for each of them. So X is an instrument for S. Z is an instrument for W. But I assume that they are excluded. And then we want to identify the third, the structural form equation. So in this case, only one is structural and the other are reduced form, right? And then I was not clear in, actually it's number 5. I did not change the number. So in here, this is what I meant. So X and Z, the instrumental variables, are uncorrelated with all three disturbance terms. It's clear. And the problem is that these are non-zero. The endogeneity is coming from this. S and W are endogenous because they may be correlated with other guys. So S is correlated with epsilon, which means epsilon is correlated with eta, and W is correlated with epsilon because psi can be correlated with epsilon. So the endogeneity is coming from correlation across these disturbance terms, right? So that's another important, that's so it's my fault. I was not clear in what it means, what I'm saying here. So what I mentioned was something like this. This is more clear statement of the assumptions. So and the same problem arises here. In this case, the equation has two regressors. So you have to consider vector, not scalar. In homework 1, I told you scalar, one single regressor, multiple regressors are different, and the formulas are different, conditions are different. So if you use the notation, identification condition is not bad, not easy to derive. Just calculate something like this, and then you have determinant non-zero condition. And so this is simple because this step is identical to the fitted value approach we learned in class, right? The only difference is z is excluded here, which means the coefficient of z is 0 in this equation. But other than that, so that makes the algebra even simpler. So that is not a problem. But the problem here is this, using the first two stages to identify the third one. That's more complicated. And what's interesting here, what you have to be careful here is, W depends on S, but when you construct the W hat, you have to use S hat. This is new because remember the idea of W hat is that you have to make W hat uncorrelated with epsilon, the error term here. But S, if you use original S, it will be correlated with epsilon. So it's not, it does not work. So you have to use S hat, which is exogenous by definition. So because S depends only on X, it's exogenous. So you have to use the exogenous one to construct W hat. And then plug that back into F. And then its algebra is more complicated because you have two regressors and each of them is separately constructed. So I define C this way, and then you have to show that the rank is 2 or the determinant is non-zero. But in this case, deriving the determinant may be a little bit cumbersome, but intuitively it's not that difficult because there are only two variables. So you can just say that correlation is not perfect. And also it should not be that difficult to show that this is implied by correlation between x and z is not perfect and delta is not 0, pi is not 0. So idea, let me show you the idea. First, if we assume there are two instruments, you need two endogenous variables, so you have two instruments. But if the two instruments are perfectly correlated, that means you only have one variable in them. So that breaks the identification. And also, they must be relevant. So relevance is implied by delta non-zero, pi non-zero. Gamma does not matter. If it does 0, still you have no problem. But problem is in delta and pi. So intuition is the correlation between z and x and delta non-zero, pi non-zero. Then you have two instruments, both are relevant, right? That's what we have. And now I'll consider what happens. We have z and x here, and the problem is it's actually multicollinearity, but easy to show the multicollinearity by showing this. So W hat can be written as a linear combination of the other regressors. So you are going to replace W with W hat and S with S hat. So W hat can be written as S hat and Z hat, Z. So definition of multicollinearity. Also in part D, definition of multicollinearity. Right? And in the last part, here I have only one endogenous variable in W, but it is only one endogenous variable. But endogenous variable, the equation for the endogenous variable has another endogenous variable. By the way, I was wrong. Excuse me. I said this is reduced form, but actually not. It is so let me fix my statement. This is reduced form, but these two guys are structural forms. So it was my mistake. I should have said it's structural because it specifies the relationship between the endogenous variables. So S causes W. So it's my fault. Anyhow, here the difference here is W depends on another endogenous variable, so we need another instrumental variable for that endogeneity. So in this case, beta does not exist, so beta is 0, so you just need to show alpha. And now it is clear, you just need to show exogeneity and full rank. Both are straightforward. It's easy to show that. Pretty clear, right? You just show that there is no multicollinearity, then you have full rank, and exogeneity is pretty straightforward. So the last question was maybe difficult, so many of you struggled in answering them, but I understand it's not, Jiahao did well in showing non-identification, so have proven observational equivalence. That is also a nice way to prove the non-identifiability. And let's see, any other comments I can make. So here, here I checked it because there is no explanation why it is multicollinear. It is true that it is not wrong. By the way, always the problem is, like in most of my homework questions, you know the answer. I give you the answer. So answering the correct answer is not the goal of this homework. You have to argue that why it is wrong, why it is correct. But I don't see why it is multicollinear. So you don't need to show this many equations. They are useless. The key point is this, and but there is kind of jump. I don't know how that shows multicollinearity. Similar, maybe here. So multicollinearity is not shown here. Another problem here is instrument is not used. Mentions relevance condition and independence condition. That means there must be an instrument, but does not use the instrument at all. So I cannot follow what Ahmad proves here, and maybe same for current. Yeah, same problem here. Instrumental variable is mentioned, but does not say what is instrument, and I cannot follow how it's related to, how these derivations are related to instrumental variable setup. Okay, this is it. I hope it helps, and I'm going to make the exam from now on, and see you. Good luck with your midterm exam, and see you later.